let's talk about prime and composite numbers. Prime numbers are numbers that are divisible by 1 and themselves. So a prime number cannot be evenly divided into any groups except groups of 1 and groups of whatever the number is. The number 7 is a prime number. It can't be divided into any number of groups except one whole group of the 7, or 7 groups with just 1 in each group. Composite, if you remember that the prefix com, C-O-M, means together, you can remember that composite means putting things together. If you write a composition, you are putting your words together. For example, a number of facts together equal a composite number. So let's say we have the number 8. 8 can be divided into different groups. 1 group of 8, 2 groups of 4, 4 groups of 2, or 8 groups of 1. So because all of those things are coming together in different types of groups, it's a composite number, not a prime number. Now, if you know your times tables really well, it's very easy to tell the difference between prime numbers and composite numbers. However, if you don't know your times tables really well, there's a couple of tricks that will help you out. What we're going to do here is we're going to look and see which one of these boxes contains only prime numbers. So, basically, we are going to do this by elimination and eliminate any box that has composite numbers, and then we'll make the assumption that if we don't find composite numbers in one of the boxes, that they will all be prime numbers. So, first of all, I look for numbers that end in an even digit, 2, 4, 6, 8, 0. And the reason behind that is because if there's a 2, 4, 6, 8, or 0, it can automatically be divided into 2 separate groups. So any number that ends in an even number is composite, except for the number 2, which is the first even number, and it can only be divided into one group with 2 in it, or 2 groups with 1 in each. So what I'm going to do is I'm going to go and I'm going to cross out all the numbers that end in 2, 4, 6, 8, or 0, because I know that unless they're the number 2, they are composite. 24 can be divided by 2, 12 can be divided by 2, 14 can be divided by 2, 6 can be divided, 20 can be divided by 2, and 6 can be divided by 2. Alright, so I have actually crossed out 1 in every single box except for box C. So we're going to go on the assumption that box C is the one box that contains only prime numbers. But there's a couple of other tricks. Let's say a number is divisible by 5. Well, then it has to end in the digit 5 or the digit 0. If you count by 5s, basically you're telling the multiples of 5, 5, 10, 15, 20, 25, 30, and they end in 5 or 0. So I'm going to cross out any number that ends in 5 or 0. Now, I skipped this number, the digit 5. And sure enough, if we count that digit as the last digit, it is a 5. But how come I skip that? Why didn't I cross it out? Well, because 5 is the first number in our list of multiples of 5. 5 is only divisible by 1 in itself, so 5 is a prime number. It's the only number ending in 5 that is not divisible, is not a composite number that's divisible by 5. Okay, so my 2 tricks right there. Crossed out a whole bunch of numbers, and you will see that box C contains only prime numbers. And take a look at that number 53. Quite a large number. Don't let it throw you off if you see a number like that, because there are some very large prime numbers. Okay? And 53 is an example of one that's very large, but there's not any number that can be divided into 53 evenly, except for 1 and 53.